What is your reason for wanting to learn mathematics? Is it because you enjoy finding patterns or solving puzzles? Perhaps it's because you have a quiz or a test coming up or an assignment that you need to complete. Or just perhaps you feel that life is nothing but a walking shadow, a poor player who struts and frets his hour upon the stage and then is heard no more. Or in other words, a tale told by an idiot, full of sound and fury, signifying nothing. And you feel that if you can't squeeze any teleology out of life itself, then perhaps you can find it in a beautiful world of pure abstraction. Well, whatever your reason for wanting to learn mathematics, you're going to love this next topic. Because today, we're talking all about radians, or as I like to call them, Radians. Radians are used to measure angles. In this way, they're very similar to degrees, although they're a lot different. The study of radians begins with a unit circle. So a unit circle is just a circle with radius 1. Remember, the radius is the distance from the center to the edge, and that's 1 here. Now, what is the circumference of a unit circle? Well, what's the circumference of any circle? The formula for circumference is given by C. The circumference is 2 pi times r. You remember pi, right? Approximately 3.14. That's our good friend. Well, what is r here? We know what it is. It's the radius, and it's 1. So 2 pi times 1 is 2 pi. The circumference of a unit circle is 2 pi. With that in mind, what are radians exactly? Well, radians measure angles by the arcs subtended by those angles in a unit circle. Okay, what does all that mumbo jumbo really mean? Well, I think we all kind of know what angles are. Right? If you have a one line segment and another one, the angle is sort of the thing in between those two line segments. Now the arc subtended by that angle is this guy here, which I denoted with S. For whatever reason, it's traditional to denote arcs or arc length by a lowercase s. So radians say that whatever this length is, that's what the value of this angle is. We're going to have some examples pretty soon. But note first that this is less arbitrary than saying that angles are measured by degrees. What are degrees exactly? Well, remember that if you measure an angle in degrees, what you're saying is that a full circle is 360 degrees, and fractions of that circle, their angle measure is defined correspondingly. But you might ask yourself, why 360? And the answer is, there is no real satisfying answer. It's arbitrary. Human beings chose that value to be convenient for them. Radians, this is how the universe measures angles. Let's proceed to some examples. We'll begin with a quarter circle. Now we know that with degree measure, a quarter circle is a quarter of 360. So 360 divided by 4, we say that this is 90 degrees. That's a right angle. But how many radians would we say this angle is? In other words, if I wanted to convert 90 degrees to so many radians, what's the answer? 90 degrees is how many radians? Well, we just said that the measure of an angle in radians is the same as the arc subtended by that angle in a unit circle. So if this is a unit circle, meaning the radius is 1, then the measure of this angle is the same as the length of this arc. Okay, the arc from here to here. And what is the length of that arc? Well, it's 1/4 of the whole circumference. The circumference is, if you took a string and you wrapped it around the circle and then measured the string, that's the circumference. And this is 1/4 of that. So remember in math, of means multiply. So this is 1/4 of, so that means multiply, the whole circumference, which we saw was 2 pi. So 1/4 times 2 pi. Now 2 pi is just 2 pi over 1. So we can multiply across 2 pi over 4. And now we can reduce. So 2 goes into 2. It also goes into 4. Goes into 2 once, 4 twice. So this ends up being 1 times pi, which is pi over 2. So 90 degrees, a right angle, equals exactly pi over 2 radians. With radians, if you want, you can write the word radians, but you don't have to. What you definitely don't want to do is you don't want to put a little degree sign. That's only for degrees. Okay? So this is pi over 2 radians. How about 180 degrees? How many radians is 180 degrees? Well, remember that 180 degrees is the measure of a linear angle. It's the angle going all the way from here to exactly the opposite direction. Okay? Now, the arc subtended by this angle is half of the whole circle of a unit circle. So half of a unit circle, the arc measure is half of the circumference. So 1/2 of is multiply, circumference is 2 pi. So this is 2 pi over 2, the answer is pi. So 180 degrees is pi radians. All right, now for 270 degrees. So 270 degrees is how many radians? Well, there's 2 ways that we can think about this. So first of all, we know that 270 degrees is 3/4 of a whole circle. So 3/4 of is multiply. The circumference of a unit circle is 2 pi, which is the same as 2 pi over 1. Okay, so this is 6 pi over 4. Both of these are divisible by 2. So this reduces to 3 pi over 2. Another way to see that, by the way, is we could have reduced before we multiplied. So right here, 2 goes into 2 once, goes into 4 twice. 3 times 1 pi is 3 pi. 2 times 1 is 2. Okay, so that's the first way to see this. Now the other way to see this is to think of this as being 3 right angles. So 270 degrees is this right angle, followed by this one, followed by that one. So therefore, it's 3 times the measure of a single right angle, which we saw before was pi over 2, and that gives us 3 pi over 2. So now, 360 degrees. 360 degrees is how many radians? Well, 360 degrees is a full rotation. So what is the arc subtended by a full rotation? Well, it's the full circle. And what's the arc length of the full circle? Well, it's just the circumference. If this is a unit circle, the circumference is 2 pi. Therefore, 360 degrees is 2 pi radians. Like I said, you don't have to write the word radian every time. You can just write 2 pi. That's fine. Finally, let's do 45 degrees. 45 degrees is how many radian? Well, 45 degrees is half of a right angle. And of means multiply in math. So this is 1/2 of 90 degrees, which we saw before was pi over 2 radians. So let's multiply across. 1 times pi is pi. 2 times 2, that's 4. So that's pi over 4 radians. Okay, so at this point we've kind of reasoned in an ad hoc way, and we were able to convert many of our standard angles from degrees to radians. And we can do similarly for other angles. For example, multiples of 45 degrees. So for instance, 135 degrees, that's 3 times 45, so that'll be 3 pi over 4 radians. What about in general? Let's say we wanted to convert 56.32 degrees to radians, or something else of that nature. We need a more general method. That's what I'll show you next.